Welcome to G Fun Facts Online, where we dive into the coolest tech shaping our future. Today, we're tackling a huge topic: artificial intelligence. AI is everywhere, right? From your phone to your smart speakers, it's changing the world. But there's a catch. This AI revolution has an insatiable appetite for power. Loads of it. Traditional computers are struggling to keep up, especially when we want AI on smaller devices, the ones we carry around, what tech folks call the edge. But what if we could build AI chips that think more like our brains? This is the incredible promise of Neuro-Inspired AI chips, and they could totally change the game for AI on the go. Think about it. The human brain is an absolute marvel. It performs incredibly complex tasks, recognizing faces, learning new things, making decisions, all while using about as much power as a dim light bulb, around 20 watts. Your high-powered gaming PC uses way more than that just idling. So, why is the brain so efficient? Traditional computers have a fundamental design, the von Neumann architecture, where memory and processing are separate. Data has to constantly shuttle back and forth, creating a bottleneck that slows things down and guzzles energy. Neuromorphic computing, the science behind these new brain-like chips, aims to copy the brain's design to smash through these limits. So what makes the brain so special for computing? Firstly, massive parallelism. Your brain has billions of neurons, all working at the same time, not one after another like many computer processors. Secondly, it's event-driven. Neurons only fire off a signal, a spike, when they have something important to say. This means only active parts of the network use significant power, unlike chips that are always on. Thirdly, memory and processing are in the same place. In the brain, the connections between neurons, called synapses, both store information and help with calculations. This is called in-memory computing, and it cuts down on all that data shuffling. And finally, synaptic plasticity. This is the brain's ability to learn by strengthening or weakening these connections based on activity. It's how we form memories. Neuro-inspired chips are now starting to build this learning ability right onto the chip itself. These neuro-inspired AI chips, or neuromorphic chips, are a whole new breed. They're not just souped-up versions of current CPUs or GPUs. They often use something called spiking neural networks, or SNNs. In SNNs, information is coded in the timing and frequency of these discrete electrical pulses, these spikes, just like in our brains. Because they only compute when there's new information, they save a massive amount of power. Several cool technologies are making these brain-like chips a reality. Spiking neural networks are key, as they mimic brain activity for better efficiency. Then there are memristors. These are tiny electronic components that can remember the amount of charge that has passed through them, making them perfect for mimicking those learning synapses. Researchers are also exploring in-memory computing more deeply, doing calculations right where data is stored, and some are even looking at analog circuits, which can mirror the continuous nature of biological processes even more closely, or hybrid designs combining the best of analog and digital. Now, why is edge computing so hungry for this brain-like efficiency? Edge computing is all about processing data locally, on your smartphone, your smartwatch, in your car, or in a tiny sensor. This brings huge challenges. These devices are often battery-powered, so ultra-low power consumption is a must. Neuromorphic chips can use as little as 1% of the power of traditional AI chips. They also need to be fast for things like self-driving cars or advanced hearing aids. The parallel processing of neuromorphic chips allows for super quick responses. Plus, processing data on the device itself is great for privacy and security, and it means the AI can work even if there's no internet connection. They're also compact, and can even learn and adapt in real time without needing to be retrained in the cloud. The potential applications are mind-blowing. Imagine autonomous vehicles making split-second decisions more efficiently, smart sensors in cities managing traffic or monitoring the environment using hardly any power, robots that learn and adapt in factories or even as personal assistants, wearable health devices that offer real-time diagnostics, like detecting an epileptic seizure before it happens. Your smartphone could have even better voice recognition and longer battery life. The list goes on. And who's making this happen? It's a buzzing ecosystem. Intel is a big name with its Loihi chips. IBM has been a pioneer and recently launched a new neuromorphic chip. Companies like BrainChip are designing ultra-low-power chips, specifically for edge AI. Qualcomm is exploring these principles for mobile devices. Startups like Sensense and Inotera are also jumping in. And let's not forget the incredible work happening in universities like Stanford and Heidelberg, pushing the fundamental science forward. Of course, it's not all smooth sailing. There are challenges. Developing new algorithms and software for these SNNs is a big one, as current AI tools aren't designed for them. Efficiently training these SNNs is another hurdle, though we're seeing good progress. Scaling these chips up to match the brain's complexity while keeping them efficient is a massive engineering task. And we need good ways to compare different designs, so standardization and benchmarking are important. But make no mistake, Neuro-Inspired AI chips could represent a true paradigm shift. We're talking about potential breakthroughs in AI capabilities, leading to more robust and adaptable intelligence. It could mean the democratization of powerful AI, bringing it to more devices and users without needing giant data centers. This also points towards a more sustainable AI, one that doesn't have such a massive energy footprint. We might even see entirely new computing architectures emerge from this research. So mimicking the brain for edge computing isn't just a cool idea, it's one of the most exciting frontiers in technology today. By learning from nature's ultimate computer, we're paving the way for a future where powerful, efficient AI is seamlessly woven into our lives, right where we need it. The journey has its challenges, but the destination, a future shaped by brain-like intelligence at the edge, is incredibly compelling. Thanks for tuning in to G Fun Facts Online. Join us next time for more glimpses into the future.